Okay. So hello, everybody. On behalf of the Digital Humanities Forum of the European Association of Jewish Studies, welcome to the first jour fixe of the academic year 2024-2025. The EAJS Digital Humanities Forum, who's hosting this event, works to promote the use of digital humanities tools in the field of Jewish studies by organizing workshops, jour fixe like this one, creating resources to help you learn these tools and other events. So please keep an eye out for further events this year. Today, we're going to have an introductory presentation on the use of Nodegoat, which is a very powerful tool for managing databases and for creating visualizations. And it's a tool created specifically with humanities scholars in mind. I was very impressed when I saw what Nodegoat could do. I'm sure you will see what I mean soon. So before starting, I just want to thank our hosts, Pim van Bree and Geert Kessels, for taking the time to operate this session and to teach us all something very useful. And of course, I want to thank Dr. Sietske van der Veen for generously coming to show us an example of how Nodegoat can be successfully utilized in Jewish studies. And finally, thank you to all of the participants for being here today. We're going to begin with Dr. van der Veen's short presentation before we move on to Pim and Geert. And we'll have time at the end for questions. So please write down any questions you have or put them in the chat and I'll collect them for later. Without further ado, let's use the time that we have. Sietske, would you like to begin?
Yes, thank you, Roy. And thank you, Roy and Anna, also for the invitation. I'm going to share my screen and hopefully also make it full screen for you. Okay, good. Yeah, thank you so much for the invitation. Yeah, to briefly talk about my use of Nodegoat for my PhD project on the Jewish Dutch elite. And I'll be very brief because I think you have to make most of your time with Pim and Geert and all the useful things they will tell you. So my dissertation was really about novel opportunities during the period between the late 19th century and the German occupation of the Netherlands. And I really highlighted people who made use of those opportunities and climbed the social ladder fast. But I also looked at patterns of integration in the lives of these Jews who were quite successful in society. And I studied the lives of more than 700 people, making use of short life stories, mostly, which are accumulated in the Dutch biography portal, which actually accumulates a lot of biographical dictionaries, so with brief life stories. And, with the questions in mind of those specific opportunities and upward social mobility, as well as integration patterns, I focused actually on 6 domains. So domain of work, education, place of residence, religion, marriage, and also associational life. So these were the domains that I looked at for seeing patterns of social mobility and integration. But I needed obviously a tool or a means of accumulating an enormous amount of information on all more than 700 people, and for this end, Excel didn't suffice. So I was really glad to discover Nodegoat, and I will just show you some short videos, which I hope will not take too slow because I'm sharing my screen, of my data set, my data model. But I want to say this is just an example. And what you see is actually because Nodegoat offers you the opportunity to build your own data model based on your own specific questions. So this is really one example, but you can do, and that's the second point, you could do much more with Nodegoat than I did. So just keep that in mind. But it's an example. And so also on the website, you can find a short use case from me, but also from lots of other people describing how Nodegoat was useful for their research. So I also recommend you look up these different use cases and see if there's anything that resembles your own research ideas and which could be an example for you. And also not be afraid to reach out to people who make use of Nodegoat for their own research and you think might be useful for your research questions. So this is what my data look like. I hope it works. Okay. And you see different the objects of person, and Pim and Geert will explain to you what objects and sub-objects are later on. But you can see that I had a lot of different things that I wanted to know for each and every person, each and every protagonist actually in my research in terms of education, different jobs. But you can also see on the left, you know, like very simple things, of course, such as gender. You can also see that the different things are cross-referenced with each other. So, for example, this political party this person was a member of, his marriages, and you can click onwards, for example, on his marriage, on his spouse, on his jobs, and really, and then zoom out again and look at the entire data set. And another thing that I want to show you is categories. When you see here on, you know, on the left of the screen, you see objects and categories. I had a lot of different categories because I had a lot of different research questions coming up also while thinking about and building the data set. So for example, different distinctions the people in my data set received from the Dutch government, but also a very, you know, very basic, actually, which category I assigned them to when I talked about like different groups within the Jewish Dutch elite. You see that you can again, you know, click on one category and see all the different people who are assigned to that category. Another object next to person, which was obviously very important, that I made in my data set was country house. So I had different country houses in my data set, and you can also see that, well, you see all the different elements that I wanted to know. And when I click on one of them, you see also that I have fewer categories than with person, but still. And also you can see here that you can make a geographical visualization with Nodegoat within your own data set. So you don't need to extract your data to another program, but you can make a geographical visualization in Nodegoat. And this is a very simple one, obviously. You know, just all these different Jewish country houses in the Netherlands. But it gives you an overview. For example, for me, it gave me an overview of this is interesting. These houses are still quite you know, quite close to Amsterdam, for example. This is one of the things that you see at a glance that you wouldn't see when you just look at an Excel file. So another example, different organizations, different associations, and you see here me using a filter. So, for example, feminist organizations that I filter on, I mean, you can devise all your different filters yourself. You see here all the different organizations that I assigned to the category of feminist organization. And again, you can click on each and every one of them, see the members, so the people that I assigned to this association, but also other different descriptions of this object. And I think I have here another example of a filter. You can also save filters. So I saved a lot of them. And here I zoom in on, for example, the different people who migrated to the Dutch East Indies, the colony of the Dutch East Indies. And you see that Nodegoat gives me all these people at once. So, and then I can filter them into different other groups as well. And again, make this geographical visualization. And you can also make videos of this. I think I'll go through them somewhat quicker, yes. And I think, and this Pim and Geert will probably show you that obviously Nodegoat is also very, very useful for network analysis. I didn't use it to its full potential for this, but that is also one of the visualization options. So you can also visualize different nodes within networks as well. And also, what is also very important and very useful, you can also extract the data within the different filters and then extract them to other programs, such as Excel. If you want to make certain figures and graphs, you can still use the data from Nodegoat and extract it to other formats. So very briefly, I think just when you start using a new tool, and I think there might be a lot of you who already tried out different new things. You just need to give yourself time and consult the documentation that is available on the website, and the guides that really take you through all the different steps of making your own data model. And what I also found useful is really think about what you actually want to know beforehand. So before starting putting things into Nodegoat, think about your most important research questions and also how to quantify them. I mean, people who are fairly new to digital humanities, and I was like when I started my PhD, you really have to get used to the idea of quantifying questions that you normally you're not used to quantify. So but the data model asks of you that you are sometimes binary, it's yes or no, or it's a particular time period. I mean, there are obviously Nodegoat is built for humanities scholars, so gives you a lot of more possibilities to also be ambiguous in these kinds of things, but you have to make choices. And you also have to think about your argumentation for these choices. And for this, it really helps to draw up a data model outline before you begin. Can be very simple, start small, and also be prepared to try out things and then see that things won't work as you had envisioned them. And but I found that, I mean, if you try and just think again, go back to the guides, most of the time you find out what's wrong and you can think of a solution. And if not, reach out to Pim and Geert because they're very, very helpful. And so I had a lot of help from them as well. And go to workshops as you do today, but also, to other workshops in the future, maybe, which are more elaborate if you think of working with Nodegoat. And I wish you all the best and best of luck.
Thank you so much, Sietske. That was a wonderful example of a really successful use of Nodegoat. Thanks so much for showing us.
You're welcome.
So now I will turn it over to Pim and Geert, who can show us how you can do some of those amazing things that we just saw from the ground up.
Yeah. Thank you very much. So first of all, thank you, Roy and Anna, for organizing this. And also thank you very much to Sietske for giving such a wonderful example of how to work with Nodegoat and also really getting to the fundamentals of it, because those are really key ingredients of getting your project in a successful shape. So great to see that, and also great for you, for the other participants, as a source of inspiration. What we will be doing today, indeed, is a rather condensed version of longer workshops that we run regularly. So we run regularly workshops on working with Nodegoat, and sometimes there's some a bit longer, sometimes they're a bit shorter. So today we will really focus on introducing Nodegoat to you, and then a couple of examples where you can log in to a shared environment. And then we will end up with some tips on how to set up your data model in Nodegoat, just to get you started if you want to continue working with Nodegoat. So who are we? So we are Lab 1100, the company behind Nodegoat. I am Geert. That's Pim.
Right.
And we founded the company in 2011. When we were still studying at the University of Amsterdam, and then a professor approached us with a data set of letters in a database that they developed themselves, and asked us what to do with this data set in terms of analyzing and visualizing this data set. At that time, there was no real software available that really focused on these key aspects of time and space for digital research projects in the humanities. So then we built this ourselves. So we already knew how to program, and then we realized that we could use those programming skills also for the research questions that we were being confronted with in our within our research. So this is the visualization that you see playing on the right bottom corner. It's the first visualization that we built that visualizes a correspondence networks, so letters being sent from A to B through time and space. When we built that, we immediately saw the potential. So you can do this for letters, but you can also do this for people, paintings, pots, IDs, anything within the realm of the humanities. So then we immediately built a research platform around it that could both host the data and then also visualize that data. And this platform we called the Chronospatial Research Platform back in 2013. And then in 2015, we switched to the name of Nodegoat, and we really started offering our services to the research community and really making Nodegoat a public resource to be used. The project at the University of Amsterdam is also still running. So over a decade now, over 400 collaborators where they worked together on gathering not only these letters, so this is then the evolved visualization, but they also collected many more materials on the era of the Romantic nationalism, which they export from different angles, collected all of their data in Nodegoat, and now also have a public presentation that we can show you at the end of this presentation. Apart from that project, we are now offering Nodegoat services in over 20 countries. Over 50 institutes are using Nodegoat for institutional research projects. You see some examples here that showcase the depth and the spread of the topics that you can tackle with Nodegoat. So really any research project in humanities can be run in a Nodegoat research environment. And next to that, we also offer these individual free accounts. So the account that Sietske also used for her research project. We now have over 3,000 individual research domains on nodegoat.net. And those are free accounts that researchers use to run an individual research project. And at the end of the session, you're free to also request your own account and then start working with your own research project in Nodegoat. And that account remains active for as long as you want it to be active. There are people who have been using Nodegoat for now almost 15 years in getting their project running. Sietske also mentioned Nodegoat.net as a place with many resources. So use cases, also the guides and the documentation. And like she said, indeed, the use cases is a good place to start to learn more about the ways in which you can employ Nodegoat in your research project. And apart from that, on Nodegoat.net, you also find the guides that really take you step by step through your Nodegoat journey. And then also we have a documentation that discusses every functionality of the system. We also try to keep a Zotero library with titles, publications of people who have used Nodegoat. So the dissertation of Sietske will also find its way to this list. And that's also a good resource just to see examples of how people have used Nodegoat. We also need to admit that many people don't mention the research database, the software that they have been using, or they don't cite the software that they rely on. And then you have to guess what they have been using. But if they do, then we can include it in a list like this. All right, so what does working with Nodegoat mean? So how do you start your work in Nodegoat? And that indeed starts by creating your own data model. So that's the first step that you need to do when you start your Nodegoat research project. Is you log in, you see a completely empty environment, and this you need to populate with a data model specifically for your research project. At the end of the session, we will also give you some tips and hints on how to do that. And one point of Sietske is indeed just to start drawing your model on a piece of paper, and then implementing that data model in your Nodegoat environment. And this is really a key aspect of Nodegoat, because this allows you to really model the environment based on your specific needs. So you don't need to rely on these broader or more generic models, but you can really make a model that works for you and your questions. And once you have that model up and running, you can use Nodegoat as an individual or collaborative workspace to really create a data set, to manage the data set, to analyze the data set, and to visualize this data. And that's also really a key point of importance for Nodegoat, is that it's really used to generate new data, right? So if you approach digital humanities from a computer science perspective, then many times people expect the data to be there already. From a perspective in Nodegoat, we usually see that data is created within the environment by the research project that is running this environment, and that can be shorter term projects, so a couple of years. But we also have been running projects now for over 10 years. We really log in on a day-to-day basis with a larger team to really create data based on primary source material, and then this is really your primary data store where you work and manage your data. Once you have that, you can also start thinking about publishing your data. So there are various ways in which you can publish your data, so you are always able to extract your data, so the data itself from Nodegoat, but you can also publish your entire data set. You can also publish interactive visualizations, perhaps also even in a mobile app. So there are a lot of opportunities there because you are already working online. You can then relatively straightforward also share that data with a wider audience via public presentations. And once you are there, you're always free to go back to point one and then implement new parts of a data model and then restart your iteration. So it's really also very much an iterative piece of software where you can continue to work on the same data set for a longer period of time. So this is a list of a fair amount of Nodegoat functionalities. We won't go over all of them, so we don't have enough time to discuss this in depth. But it all starts by the implementation of your own research model, your data model in Nodegoat, and then all the other functionalities, they form itself based on your model. So that also means that you can be flexible in the complexity of your research environment. So if you make a relatively simple model, all the other functionalities will also offer a very straightforward user experience. If you make a very complex model with lots of nuances, lots of references, then your entire environment will also be much more complex. So this is also something to take into account. And the approach that Sietske mentioned, to start small with a simple model and then gradually build the complexity up, is really a good approach to also better learn what you can do with all of these features. So just to give you an overview, so Nodegoat is also really geared towards these larger research projects where you can work with multiple projects, multiple users, various clearance levels. Also version control is an important aspect here, where you're able to really see your data grow also from a historical perspective, but also you're also able then to work with students, for example, in a project, and see who does what, right? And then you can promote students once they have once you trust them enough to really enter data, then they can make a promotion in your clearance level structure, and then really build this data set together. Yeah, so a lot of focus on interconnectivity. So Nodegoat is a very open system where you can always import, export your data, share it with a wider audience. And we recently also created a new functionality, a new data publication module with which you can extract your entire data set, also with a representation of the model from your research environment. So this is really a key feature to create data publications that you can upload to Zenodo. And we really recommend to do that every now and then to also show the wider research community what you're doing and to also allow the reuse of your data. So Nodegoat also offers functionality in text, working with texts, text tagging, reconciliation processes. You can also upload sources. So if you have primary source material, you can also upload those and then also do source referencing very specifically. And then there are various functionalities based on the analysis of your data. So again, this is very much dependent on how you structure your model. And in a very complex model, you have very complex opportunities for filtering, for path-based analysis, and also for creating very complex visualizations. All right, so we now log into a environment just as part of this demonstration. In a moment, you will also be able to log in and then we can work together. But this is just to show you how a environment works. So it all starts by implementing a data model. So Sietske made an implementation specifically for her project. This is the project that we started with in 2011, 2012. And this is then a data model as another example. So it's very important for you to remember that whatever you see here is just a data model. Your data model can be completely different, really take a different focus based on the needs of your research project. So here we see, for example, a person, how a person has been defined in terms of object descriptions, family name, given name. So these object descriptions, they allow you to describe a person. And then we have various sub-objects here. So a sub-object for a birth, where you can combine a date statement and a location statement. And these sub-objects are really unique, or what makes Nodegoat unique as a system that is built for research in the humanities. Because with these sub-objects, you can assign various statements to objects with various temporal and spatial attributes. So for a birth, you can have a temporal and spatial attribute for a place of residence as well, for a death as well, but also capacities. So if a person has a capacity for a period of time at an institute, you're also able to store that and visualize this within such a system. So if you then go to data and go to person, if you then look for a single person here, here we have the person of Jacob Grimm, the fairy tale collector. Then we see that we have three object descriptions defined, family name, given name, and an external identifier to allow for a interoperability of your data set. And then we have 6 sub-objects defined where we have a birth, a couple of places of residence, and also then a death. And once you have stored data like this in your environment, you can then run the geographical visualization and then visualize this data through time and space. So that's the essential part here, how you can work with your data. So this we can do for a person, but we can also do this for a letter, for example. So for a letter, we can also define moments in time and space. So if we open up one letter, we see here again a set of object descriptions. So who sent the letter, who received the letter, when was it, where was it published, etc. Some information about uncertainty in your database. And then we have 2 moments in space and time, one for the moment of sending and one for the moment of receiving of that letter. And once you have defined these 2 moments in time and space, you can then run a geographical visualization and then see that single letter pop up on the map, and then also use the time slider to look at this data set through time. So now the data is not visible because it falls outside of the time frame. If we then move the time frame further, we see that the data set or the data falls within the time frame and is visible. So this we can do for a geographical visualization, but we can also run a social visualization where we simply visualize the relationships that have been defined here. So we have in red the letter itself, and then we have one for the sender and one for the receiver, and also one object for the publication, so the publication in which this letter was published. So this is then also a very straightforward visualization, which again is temporally aware. So we can then use the time slider to either make the dataset active or inactive. Obviously, one person and one letter is not that exciting, but it's good to know what the basic ingredients are when we look at the dataset. So now if we broaden our scope and then look at a larger set of data. So now if we do a quick search for the last name Grimm, we find a little less than 1,000 letters of the brothers, and I think also one sister, Grimm. Then we can run here the geographical visualization. And then we see all that data plotted on the map in one go. These are the kinds of visualizations that any visualization software offers you that is not temporally aware. And this is not that helpful because nobody has the same network throughout their lifetime. Networks change over time. So this temporal aspect is very important here. Now, what you also see here is this legend. So these sub-objects, sender and receiver, have different colors. And those are visible here, where you see these pie charts per location, how many letters were sent and how many letters were received. So here you see immediately in Kassel, more letters were sent than received. And in Berlin, more letters were received than sent. So this is already some information that you can extract from this. But it really becomes understandable once you make the time slider smaller, and then once you start navigating through time. So then you see exactly what their network was at this moment in time. We will also see the centers shift. So now the center is around Kassel. They live and work there and correspond with various other locations. And we also see here a fairly well distributed network, also with many ties in Central Europe. If we then move further in time, we see that the center of the network shifts from Kassel to Berlin. So Jacob Grimm got a position there, but also that the ties to Central Europe now start to disappear, and a more Western and Northern European network emerges. So this is something that you then can just see by exploring this network. And that point of exploration is of key importance here, because that's what we also see as the most valuable aspect of these visualizations. So we'll never tell you that these visualizations bring you any answers or things that you can see and then state, okay, this is a true representation of how things were at that time. But they always, they will not give you that, but they will give you questions, right? So now a question pops up like, how did this change occur? So why did this change in the network happen? And this brings you then a new perspective that you can then test with your source material, and really bring you a different focal point. All these networks are also interactive, so you can always hover over data points, click on them, and then really immediately go also to the detail of it and then see what the data is behind a specific network visualization. So this we can do from a geographical perspective, but also from a social perspective. So here we see then a social network representation of these letters, where we can also either look at the entire network like this, or make the time scale smaller and then move through the network to see exactly what the social network was at what point in time, and how people would move from the periphery of the network to the center and vice versa. And then we also have chronological visualization, just to show you the temporal distribution of this data. All right, so this is then from the perspective of the letter. All the senders and receivers are entered as links to the object type of person. So we can also go back to the object type of person. And if we then look for the person of Jacob Grimm again, we can open up this person. We see the biography that we just have been looking at. But we also have this cross-reference tab where we can see all the letters that Jacob Grimm has sent. So then we see that he has been acting as a sender in 430 letters. And what we can distill from this is that we know that he probably was at the location where he sent a letter from, or was close to that location. So this is also an example of how you can recreate more of a data-driven biography by visualizing all the sending locations of a person. So we do this by opening a scope, looking at the birth and the death, and then going from person to letter via the sender relationship. And then we're only interested in seeing the sub-objects where this person acted as a sender. If we apply this and then run the geographical visualization, oops, let's select Jacob Grimm. As a sender, sorry. And what we then get is a similar visualization of their biography, but now we have much more stops in between. So now we also see that he was born in near Frankfurt am Main. And then if we move the time slider further, we see that every blip is the sending of a letter. And then you can really follow his path through Europe to see where he went and from which locations they sent letters. So then from Kassel to Göttingen, also back, and then to Leipzig, and then finally also to Berlin, where he eventually got a position. What you also see here is that there's no direct line from Göttingen to Berlin, but because he was kicked out by the King of Hanover, he had to go back to Kassel, and then from Kassel to Berlin to get his position there. So this is then a way of looking at that network. Obviously, his itinerary is not that exciting. We also have a person here with a bit a more broader reach. So this person has sent a little less than 200 letters. And if we visualize their network in the same time, we can really see these kind of expeditions of these 19th century intellectuals, and then see where they went to collect data for their research topics. All right, so this is then more of a geographical exploration. The entire social network can also be visualized just to see all of the letters and the people being connected by these letters. If you run that network like this, you see the data set with these larger ego networks, all the letters that they have sent, and then the people in between. This we can also then explore through time, and then this entire network can be inspected. Obviously, because we have so much data here, it's not so easy to read. And here it might have been better to collapse this multi-mode network, so a network of letters and people and publications, into a single mode network where we don't see all the letters in between, but just the direct links between people that represent the letters that they sent and received. And to do that, we can go to person. I can open a scenario, a set of settings, where we now have a scope applied that goes from the person to the letter. and then again from the letter to the person, and it collapses all the letters in between two people. And we also have run a analysis on betweener centrality that also highlights important people within the network, so people who are important for the structure of the network. And if we then run this visualization here, we now see a much more cleaner representation of exactly the same data, but by collapsing the letters that are in between and by highlighting the betweener centrality of the people, you then get a very clean visualization of the people in the network, the people that are connected to this person that are all dead ends. So this person has a lot of correspondence, but they are not of value to the network. The same goes for this person. And this person here has not so many correspondents, but they are all of key importance to the structure of the network. So then you see immediately that this is a key figure, a broker, so to say, in your network who is able to distribute information through these three networks. So this person is the most efficient route from this network to that network, and from both of these networks to the larger network over here. So that's something that you can highlight by running an algorithm like betweener centrality and then looking at the data from that perspective. So once you've run a couple of these modes of analysis, you can also think about how to look at your data from a different perspective, also highlighting uncertainties. And with that, we can also here run your data on different background maps. So this is a map, a geodesic representation of a geometry in 19th century Europe, where you're able then to run your data on such a map and also highlight the data that you are uncertain about. So Nodegoat has a lot of functionalities that allow you to define uncertain locations, uncertain dates, where you are able to define when a letter was sent. So for example, this letter was sent between two other letters, or it was sent 1 month after this summer semester and before another letter was sent. So you can make really complex, vague date statements that you then can highlight and say, okay, this is uncertain. We can hide it in our visualization to only look at the data that we are certain about, or say, okay, these are also some educated guesses that we can include to have a more comprehensive overview. And you can also do something like this for more engaging map. So if you want to look at your data also on a historical map, you can also identify the historical background. So a historical map. And then if this server is cooperative, we can also see some of that data appearing. Yeah, there we go. So this is then a background map of the of that era, where you can also then see how this person interacted with the people inside and outside of the Austrian-Hungarian Empire. Okay, so this is a couple of examples from a demo environment. Other examples you can think about is this project at the University of Bern, where we're working to analyze the geographical origins, one of the topics of people who came to various universities in medieval Europe. You can also go very much small scale to analyze inner city landscapes. This is a project at the University of Leiden. We have many other projects that really look at how relationships within a city works. Also one project from a researcher in Bordeaux who's analyzing the Venice ghetto to see relationships within that area. This is then more a focus on social ties, so you can also work on that kind of less looking at the geographical relationships, but more at the social relationships. And that can also be done much more small scale. So to really look at how, for example, topics interrelate to each other. And then very briefly, this is something that you can also explore later on. If you look for the Encyclopedia of Romantic Nationalism in Europe, you can also look here at how a Nodegoat dataset can be published online in various manners. All right, so yeah, it runs in the browser. After the session, please request an account on nodegoat.net if you would like to start using Nodegoat for your own research project. For larger projects, we also provide paid services. So that's how we run our company, that projects who have funding, they hire us to provide training events, workshops, service support, etc. Nodegoat is also open source, so you can also run it yourself. There's via the release page on nodegoat.net. You can also go to GitHub and find the source code. Yeah, so now for the interactive part of this session. If you have already a Nodegoat account, please log out of your personal account and then log in with the following credentials. So you will all receive a number, and with that number, you can create a username, and that username will then be, for example, workshop 1 without the brackets. So if you are already logged in, you can log out. And then after you received a number, you can type this workshop 1, and then the password is Den Haag. So I will call everybody by their name, and I will start at the bottom of the list, and I will make my way up, and then you will all receive a number, and with that number you can log in via the instructions on screen. I start by Sionit Fatal Cooperwasser. You are number 1. Then Rugama Johnson Bloom, you are 2. Then Netta Cohen, you are 3. Maximilian de Molière, you are 4. Marcin Wojcinski, you are 5. Katja Uleszkiewicz, you are 6. Kajetan Holecek, you are 7. Hanna Holzschneider, you are 8. Giordano Bottecchia, you are 9. Daniel Stukel, you are 10. Daniel Katz, you are 11. Andrea Schatz, you are 12. Anna Tsiric Pavlovic, you are 13. Ali B. Langrudi, you are 14. Aaron F., you are 15. Anna Zabarniak, you are 16. Sitske, if you want to join, you are 17. Roy, you are 18. Okay, everybody got their number, and then just log in with workshop 1 or workshop 18, and then the password is Den Haag. Okay. I will also log in. All right. So please raise your hand or say something in the chat if you are unable to log in. What you will be seeing is a research project like this with the name workshop. And you might be in a different project than the project biographical data. The idea is that you all go to the project biographical data, and you do this by clicking on the arrow on the right and then selecting biographical data. So if you are in correspondence data or correspondence networks, for example, you click on the little arrow and then switch to biographical data. All right. So what we see here is again a different data model where we have a person, an object type person, object type place, object type institutes, and object type nuclear family. For now, we will focus on place and person. So to see what we are about to do, you can open the object Desiderius Erasmus. And then you see the name of Desiderius Erasmus. You see 2 external identifiers, some biographical notes, and then 30 sub-objects. And what you can do here is you can inspect these sub-objects. So you see a date start and date end. And then we have places that are associated with these sub-objects. If you click on one of these places, so for example, on Gouda, you are sent to a different object in the database where we now see all the attributes of Gouda. So this is the essential point in working with a relational database, is that you have relationships in a database like this that you can follow, and then you go to the object of Gouda that exists independently of this relationship. So we have one object of Gouda where we have their names, and then also, very important here, the geographical information that allows us to plot Gouda on a map. So in order to make a plot, you need to tell the map where Gouda is. And in this case, we have a point data, latitude and longitude. And these numbers you need to put in order to tell any geographical information system where this location is placed. The good thing of identifying these objects in your database is that you can reuse them. So once you have entered Gouda into your environment, you can then reuse it somewhere else, here again, where now you don't need to enter that data anymore. It's already in the system, and you just refer again to Gouda. And this is an important part that you need to remember when you are building up your own database, is that you enter this data, you can make a relationship to it, and then you can reuse it whenever it becomes relevant again. This is also what we will be doing today. So in a moment, we will first enter a place, so a populated place or a city. And then in a second step, you will all enter a person. And these two things, they need to interrelate. So if you enter Den Haag, for example, your person can then have a reference to the place of Den Haag that you just entered. We'll do it step by step, so you can just follow the steps on screen. And then what you might end up with is a visualization like this. So if you click here on the geographical visualization, you will see the itinerary, the biography of Desiderius Erasmus that you can now also explore through time. So here you can make the time slider smaller and then either enlarge it like this. So then you look at how the data grows, or you can make the time slider small and then grab it and move it around to look at a specific period in this data set. So feel free to work with these interactions yourself as well. And the idea is now that we together enter some data here that can be worked also in this regard. So to enter data, we first need to enter a place that we then in a second step can refer to. So we can go first to place. Then we see here a list of 17 places that are already entered into the system. And we will all now start by entering one new place. So I will enter Den Haag, and you can enter all a place of your own choice that you then later can use in the person that you are about to add. By the way, this person can be anybody, can be a historical figure, can be yourself, can be a fictional character, doesn't really matter. We will now just do this to teach you how to work with a system that already has been set up. So you go to place, and you go to add place. And then first we enter the name of the place. So a object description. I will enter Den Haag. And then we can also then enter alternative names. So you don't need to make a choice here specifically. You can then have the alternative names also as part of your database like this. What is it in French? La Haye. Then we can also add a external identifier to your data set. This is a bad practice, a good practice to make your data set interoperable. So you can do this by querying the GeoNames API and then waiting for the results. and then you can select one of the locations in the GeoNames database. So you can also find more about this interaction in the Nodegoat guides. So this is really a key element of making your data interoperable and reusable by others. And then we can also classify your location. So this is how we use classifications in Nodegoat, just lists of labels that you can use to classify your data set. Here you can see that this is, again, really up to you in your own project, whether you want to classify something like a country or a region or a populated place. Those are really decisions that you need to make later on when you work on this. And then for the location, we can enter point data. There are various options in Nodegoat to enter location data. Here we will enter a point data. You can either paste that in. So if you have that data already available, you can enter it here. You can also import data to Nodegoat. So if you have already lists of data, or you already have a database or an Excel sheets, you can import that data also. So you don't need to manually enter all of your data in Nodegoat. And on nodegoat.net, there are also many guides on how to import data. If you don't have that latitude and longitude value lying around, you can then also click on map and then find your location on the map, zoom in, and then just select roughly where you want this point to be. Again, the precision is something that you can define later on. For this exercise, it doesn't really matter. It's just fine to have a place and a point in the database. So once you've entered a location and also a point data, you can click Save Place, and your data will then be part of the data set. The form stays open. The reason for that is that you can continue to work on your data set. So especially if you're doing manual data entry, this can be very handy, because now you can continue to the next point. In this case, we don't want to continue, so then you click Cancel, and then the form closes. To see all the data that you have entered, we can now click on the object type Place again, and then we see all of the data that you have entered today. This data as a gazetteer, this list of locations, we can also visualize. And if we do that, we now see all of the data that has been entered into this list of locations. So you can here run the geographic visualization, and then you see all the locations that have been entered. All right, so this is then for place data and how you enter that into Nodegoat. Now we switch to person, and then we can add a person to our environment. So you click Add Person, and then here you see all the object descriptions that you can enter. Again, just to stress this once more, these are just the object descriptions that we use for this project. In your own project, later on when you are building your own environment, you are free to use any object description that you would like. We first have some general object descriptions like family name, given name. So let's start by that. Let's enter a family name and let's enter a given name. So again, this can be any person that you would like to enter some information about. These are just strings, so kind of pieces of text in your database. And then here we also have gender. And if we click on gender, a list appears of options. So this is also a set of options that has already been entered here. But again, this can be done by you in your own environment in any way you would like. So here you can select one gender, and then this is the way how this model works. If you want, you can also set this in the model to be a multi-field, so you can assign multi-genders to a person, and you could also assign this as a sub-object, so you could also assign periodizations to genders. So if somebody identified first as one gender, you can store that as a sub-object, and then once they change to a different gender, you can say from that age they were a other gender. Since we run a lot of historical projects, we don't see that happen that often. But what we do see a lot of times happen is religion. So if somebody converted, then you have a sub-object religion, and you see them from their baptism until a point to be Catholic, and then from 1 year or a specific date onwards, they identified as Protestant or Lutheran, and then you can store that in your database with a temporality assigned to it. Okay, let's save this person now just as a very simple statement. So we save the person, and then again, the form stays open, and you can cancel it to close it. So to see the latest version of the data set, you can click person again, and then we have the list of all the people that are in the database. To edit a person, you find your person in the list again, and then on the right side, you have a blue edit button. If you click that edit button, the form opens up again, and you can start editing your object once more. So this is the interaction. If you want to update data, the form then just reopens with your data in it. And then what you can do now is also enter some biographical notes, like this is just a dummy text. And then if you save this, your object will be updated. What I did here is I clicked save a bit quicker than most of you, and then you see these locks here. So if somebody is editing an object, nobody else can work on that same object because it's locked for editing by that person. All right, so now we have created an object, and we also have edited that object. Now let's assign a sub-object to your object, so you're able also to visualize your data through time and space. So in order to do that, let's find your object in the list again and click edit. If you don't see the edit form open, it might be that you need to scroll up. So if you click edit and nothing happens, like this, then just scroll up and your edit screen will be there. Okay, like this. And then we go to the sub-objects editor and you click on birth for the plus, on the plus sign. Then the sub-object birth opens and we can identify a birth moment in time and space for this specific person. The birth sub-object, as you can see, consists of a collection of statements. So that's how a sub-object works. So we have here a date, a location, and then some additional statements as well. And that's really the essential part of working with Nodegoat, that you are able to make these combined statements. So for the date, again, we have various options here that you can also read about more in the guides and documentations, where you also would be able to say, okay, this person was born during the Bronze Age, and then you don't need to define Bronze Age every time. You just reference a different period. And you can also make very elaborate date statements with the chronology statements, like this person was born probably 5 days before their baptism document was signed. But now we just do a point, and the way how you enter a date in Nodegoat can also be done in various manners. So you can do a day dash month dash year. The standard way of reading and entering a date. If you don't know the day, you can also omit the day and you do just a month dash year. If you don't know the month as well, you can also just enter the year. If you're working before the common era, you can also use the dash as a minus to identify that this happened before the common era. If you prefer to work the other way around, so year, month, day, you can also do that, and then also use the same steps there.
Can you enter alternative days?
You mean alternative calendars or dates?
No, I mean if I'm not sure about the date.
Yeah, if you're not sure about the date, then you can either opt, we can talk about in a moment, to work with periods. So that's how the place of residence is now configured. But you can also then go to chronology and then enter a chronology statement where you say this date was between two statements. So it was, for example, 5 years before the begin of 1986 and 5 years after the end of 1986. So what you're doing here is you're quantifying your uncertainty. So what we see a lot of people doing is if they're not certain about the dates, they write around, or they just do a question mark or circa. And with this, you state, if I say around, I mean either 5 years before or 5 years after a specific date, which makes your date actionable. So we can count with that date, and which is also very transparent to your peers, because somebody else might interpret around as 10 years before or 10 years after. So this is a much cleaner way of storing that. And here you could then also make relational statements like 5 years before the birth of somebody else. Or if you know, for example, that somebody started studying and you don't know exactly when, but you know when they were born, that you could say this happened probably 18 or 20 years after their birth. So in that way, you can just use a couple of dates that you know and then extrapolate many other dates based on that.
But what I actually meant is much simpler historical situation when you have information about a person who was born either 1860 or 1862.
Yeah, then what you then would do here is to make additional sub-object descriptions where you also enter other date statements. Or in this case, we only have one birth sub-object. And you can also configure the system to allow for multiple births. So then you assign multiple births to a person, and one you state as this date, and then you make a new birth statement with the other date, and you can then both assign these statements to different sources. So you can also say we have that source on page 4 where this date was mentioned, and then another birth date is connected to a different source. Does it answer your question?
Yeah, thank you very much. It's very clear. Thanks.
All right, so here now let's just write one date. So all the vaguenesses and nuances can be defined by yourself when you make your own model, and then you can also allow for multiple births per person. Here now we also want to make a location reference. So you can either look for the location that you want to link to. If your location is not in the list, you can then also click here on New and then write or create that location. So you're able to define locations also as you move forward by just creating that new location into your database, which will then exist in your database, and you're able to reuse it later on again. Like this. So now we have created a new place in the database and then immediately assigned this also to that person. These vagueness statements, you can just leave for what they are. You can click Save Person, and then now we have data that we can visualize. So either you can open one specific person and then click on the geographic visualization, and then you see this person in their location, or you can close this person and then run the entire data set as a geographic visualization. And then we see not only now Erasmus, but we also see also all the places where people were born, and also now also some deaths of people entered into the environment. So this is how you enter data in a pre-configured research environment. we usually do much more steps here to show you also how to make relationships and how to enter more complex data. Today we don't have time for that. So what we want to advise you is, if you start working on your own research environment, to really focus on the model that you would like to implement. So once you have your account, really start thinking first about this conceptual data model, then also create a logical data model where you describe every relationship that you need, and only then make an implementation of that in your application. So these 3 steps are really of key importance, that you focus first outside of Nodegoat on your conceptual data model, then outside of Nodegoat also on your logical data model, and only then make an implementation of that in your Nodegoat database. And as Sietske mentioned, this can be done very well in a more iterative approach, that you start with a simple data model, then make a simple logical model, and then make an implementation of that in your Nodegoat environment. Learn from that, see what went well and what didn't go so well, and then you can update your model based on the things that you've learned. All right, so I think, Roy, you wanted to have 15 minutes for questions. So we're happy to take any questions that you have.
Okay. Yes, thank you so much. Let's definitely move on to some questions. I'm sure everybody has some from this amazing presentation. So I received 2 separately, but of course, everybody, if you have questions, please either put them in the chat or raise your hand, and we can move on like that. For now, I'll invite Daniel Katz had a direct question to me. Daniel, do you want to ask your question? Would you like me to ask for you?
Yes, I can ask it. Thank you. I had 2 questions. One was whether I can use this to do an historical family tree, and the other is whether I can use it to make a customized map for the various travels of the figure I'm researching, and whether I can show all of his travels together or each one individually with customized place names, and then whether I can just export that and use it, publish it in an article or in a book.
Yes, just to give you an answer. So in terms of mapping family trees, our advice usually is then to make a object type called nuclear family, where you are able to define or find the people in your database, like Desiderius, Erasmus, and Goethe together had a child called Alice Oppenheim. And then you could also define a marriage for this. And what you are able to do with this is you are using a very straightforward model where we can save this. And then if we now, if a new object is defined here, where Alice is one of the partners together with another person, and they have then a child, then now we are entering a multi-generational family here in a structure that is very easy to look at. And if you then would look at one person here and then go to cross-referenced, you see immediately where they were acting as a child or where they were acting as one of the partners in their marriage. Here you can also define husband, wife, some more traditional names for roles in a nuclear family, but you can also work with persons just to identify that people play a role in a nuclear family. So yes, this logic is used by many scholars who are mapping family trees in Nodegoat. And then in terms of your second question, so what you saw here with Erasmus, where we have this itinerary of this person plotted on a map. So the background that you see here is a very default Google tile, and this can be defined by you. So what you see here as a map, you can have various tile servers that you connect to your Nodegoat research environment, and then you can have your own custom maps also in your visualization. Here we have a guide that walks you through these steps. So in the guides section, working with spatial data, we have the guide use a historical map, where this is completely described in how to get a custom map as a background for your visualization.
Mhm.
Does it answer your question?
Yes, thank you. One more question about the family tree. I have somebody who married his cousin, and this has caused all sorts of problems in a tree that I did on Ancestry.com.
Yeah,
How
here
would
it
it
doesn't
work
matter.
here?
So here you just it will just be a if we remove this here, here we don't have the like the family tree visualization, the classical one. It will just
Right.
show you the ties that have been identified within the system.
Mhm.
Okay. I have a question from Sionit who left a little bit ago. I just want to ask it here. She's asking about the possibility of using this for analyzing autobiographies. And I know we have a lot of other scholars who analyze text. Is there a means to use like a large body of text that somebody has to pick out locations or something like that? Is there a way of using a Nodegoat for this kind of analysis?
Sure, yeah. So the way then how you store your texts in Nodegoat is really up to you how you would like to store that. We usually advise then to cut up a text like that into chapters or pages, and then add that into your Nodegoat environment. And once you have these pieces of text in your environment, you can also start text tagging. This is something that we have not done in this exercise, but in Nodegoat you can do text tagging also specifically on any pages in autobiographies. So that's then a very more of a non-structured approach to the data that you find in this autobiography. And that's really something for you to discuss, because you can either do it as a text. So this is just a dummy text. I am planning to go to Bologna. Then here, this can be stored as a text tag as such. Then we have that as a tag in your text, but you can also think about storing these statements as more structural statements where you make a new sub-object called travel plans or travels, and you store that data as structured information. Both approaches work. Both approaches have different advantages and disadvantages, and then it's for you to decide what works well specifically for your sources and your research question.
Okay, thank you. We have a question from Aaron. Uh, Aaron's asking about if you could say a little bit more about creating scenarios and exporting them, because he's doing a project that has to do with manuscripts. Aaron, feel
Yes,
free to
sure.
jump in if you'd like.
Yeah, so here a scenario is a set of functions, a set of configurations. So here we can make a filter and say, show me everybody with a in their name. And I apply this filter, and then this is a result of that filter. This filter can be stored, so I can click here on save, and I can store a filter that I call people with an A in their name. I can save this filter, and now we have one piece of configuration in the system. Another piece of configuration would be a scope. So here we can say from all of these people with an A in their name, we only want to see a birth. So with the scope, you can either limit what you see from the model or expand what you see from the model. So I can save this scope as well. I can say birth only. I can save this. And then the scenario allows you to make a combination of these settings. So if I here click on manage scenarios and I click on store to create a new one, I can give this a name like birth places of people with an A, and then I can select a filter that I just stored. I can select a scope that I just stored. I can click Save. Now this scenario exists here. I can select it and then run it, and then the filter will be applied, the scope will be applied, and I can run now a geographical visualization of all the people with an A in their name, just looking at the places where they were born. And this is something that is now part of your system. And in terms of exporting this, this is something that you can then enable in a public user interface. So if you have in your system also the public user interfaces enabled, you can select it there to also publish it. And here you can also export the data that is part of this to share that with other people. Does it answer your question, Aaron?
Okay. I hope it did. It was very detailed. I invite anybody else to also ask some questions right now. Hannah,
There's a question of Hannah. We can share the slides with you, Roy, and then you can share these slides with all of the participants to see these slides as well. And also, just as a piece of information, so we run these workshops regularly, and we're always open to organize them. So if you have an opportunity to organize a Nodegoat workshop, just get in touch with us, and then we can also organize perhaps an in-person workshop that could be a bit longer, where we then also focus more, just like we did in Groningen, Roy, on this specific question of how do you actually create a data model, and how do you then implement that data model in your research environment. Yes.
I think everybody, even if sometimes I think it's a very powerful tool and it can look a little bit intimidating, I think it's clear that with a little bit of scaffolding, you start at the bottom and then build up a little bit more. It becomes much more easily usable with a little bit of time and experience. And I really recommend everyone to reach out with questions that they have. Do we have any more questions before we end? We have a few more minutes that we could ask some questions. Daniel, I see that your hand is
Yes, I have a
raised.
question. You mentioned starting with simple models, starting with a simple data model, and then making a logical model. My question is, what is the difference between a data model and a logical model?
Yeah, so here, so the conceptual data model consists of the different types of information that you would like to store. So in this case, you might be looking at books, at people that might work as authors or publishers, and cities where these books can be published. So a conceptual data model is just that, and it really is a thinking exercise for you to identify what are the types, the different kinds of information that I would like to work with, and how do they, in a very general level, relate to each other. And the thing here is that it asks you to think about your research project in a more abstract level. And this can be something, if you're working with manuscript, for example, where you have maybe letters or publications or etc. You can just store them as manuscripts and then tag them. This is a letter. This is a publication. This might be a contract, etc. So it really asks you to think in various ways of abstraction about your research project. Once you have that kind of a clear picture of that, you can move to the logical data model, where you then write down for every type of information, what are the attributes that you need. So for a book, you might need a publication date. You might need a title. You might need an author. You might need a publication city. And then for a person that acts as an author, you can write the kinds of information that you need for that person. So family name, given name, gender, place of birth, date of birth, But then the question is, do you really need a place of birth and a date of birth for your person? And this can be also kind of a trap that you then first conceptualize a model that looks good on paper, that you can implement, but then you start doing the data entry, and it turns out that it's too complex, and the model asks too much from you, also about data points that you might not need for your research project. So you can also kind of become a prisoner of your own model, where you then think, okay, I need also this birthplace of that person, and you spend days in the archive just to find that. But in the end, if you're just interested in co-authorship relationships, it doesn't really matter, right? So that's really for you also to think about what are the points of information that I need for every information, kind of information that I'm storing. Does that make sense?
Yes, thank you.
Welcome.
Okay, so what I'll do is I will mention, as Anna did here in the comments, that there are really great manuals on the Nodegoat website that everyone can easily take a look at. But we are running out of time here, so I think that we can, unless we have any last-minute questions, I think we can close this jour fixe. I want to say thank you very much, Pim and Geert. It was wonderful. Thank you so much for coming. Thank you to Sietske, who is not in the chat anymore, but who was here. Thank you so much, Dr. van der Veen. Thank you, everybody, for coming. We will keep you updated on the future events. I will send out the slides from this presentation to everybody and a link to the video, which will also be uploaded to the European Association of Jewish Studies website in the Digital Humanities Forum section. Thank you, everybody, again. I hope you have a great day.
Thank you.
Thank you.
Bye-bye.
Bye, everybody.